Hey everyone, and welcome back to our APES Flipped Classroom where we are winding up Unit 3. We'll be discussing human population dynamics today, as well as industrial transition. So we're going to begin with 3.8, which is human population dynamics. And we're going to begin with a quick discussion of an English economist whose name was Thomas Malthus. And we'll often hear when we talk about environmental science and when we talk about human populations, Malthusian economics. And so Thomas Malthus took the ecology concept of carrying capacity, and he said, looked at the way that human population was growing, which we can see was this exponential growth, this J-shaped curve. So human population was growing exponentially, but realized that our ability to produce food was only growing in a linear fashion. And so he predicted that when the exponential growth of humans met up with the linear ability of food production to grow, that we were going to have what is now considered a Malthusian catastrophe. And what that means is that humans were going to overshoot their carrying capacity. We were going to have more humans than we were capable of producing food. So this obviously has not yet happened, but let's talk a little bit about why. So jump here. So Malthus theorized that Earth has a carrying capacity for humans, just like every ecosystem has a carrying capacity for the organisms that live in that ecosystem, and that our limiting factor was probably going to be food production. And so Malthus predicted that when these two things intersected, that we were going to have plagues and war and strife, and that was going to limit the human population because our population growth was happening faster than food production growth. What Malthus failed to anticipate was that humans are incredibly resourceful. We're very good at developing technology. And so we have actually altered the carrying capacity of Earth with technology and innovation. The biggest way that we have done that, and the most significant contribution, is the development of synthetic fertilizer in 1918 as part of the Haber-Bosch process, and which we figured out how to turn atmospheric nitrogen into nitrates, which were capable of fertilizing our crops. This is furthered by what is called the Green Revolution in the 1940s, which again increased our ability to produce food, our ability to have higher yields out of each acre of cropland. And both of those have dramatically increased the food supply for Earth. So we can see that Malthus predicted that we would surpass our ability to produce food. We can see that our innovation brought our ability to produce food up. We can see that we had exponential growth between 1900 and 2014 in our ability to produce grains. And so the technology has prevented us from exceeding that carrying capacity. Now, with that said, most economists and ecologists do agree that there probably is a carrying capacity for humans on Earth, but our ability to innovate and to create technology to increase our food supply makes that very, very difficult to project. Probably most ecologists and economists agree that it is probably about 10 billion people, and we are past 8 billion, rapidly approaching 9 billion humans on Earth. And one of the big limitations now is arable land. So the amount of land that is available that has sufficient nutrients and sufficient water in order to grow crops. Okay, so in order to talk about how human populations grow, we need to be able to calculate how those human populations grow. And we have gone over these in class, so we're just going to have a quick review. But we know that growth rate or natural growth rate is the percent increase in a population, and that's usually the percent per year. So a growth rate of 5% for a population of 100 means that in a year, that population will have 105 people. Now, growth rate is in percent. Crude birth rate and crude death rate are both per 1,000 people in a population. And so remember that we calculate crude birth rate by taking the number of births, dividing it by the number of people in the population, multiplying by 1,000. Same thing for deaths, number of deaths divided by the total population times 1,000. So if we have an example where we have our global crude birth rate is 20 and our crude death rate is 8, in order to calculate the growth rate, we're going to subtract crude death rate from crude birth rate and divide by 10. And so in our example, 20 minus 8 divided by 10 gives us a growth rate of 1.2%. Now, this is the natural growth rate. This does not take into account emigration and immigration, just births and deaths. So again, we're dividing by that 10 because crude birth rate and crude death rate are per 1,000 and growth rate is percent. Okay, and again, doubling time, this is the rule that you have to be able to calculate. The rule of 70 says that the amount of time in years for a population to double is equal to the number 70 divided by the growth rate expressed as a percentage. So when we have that global growth rate of 1.2%, we're going to take the number 70, we're going to divide it by 1.2, and that'll tell us that our population is going to, global population is going to double in 58.3 years. So here's our practice problem. Our country has a crude death rate of 9 and a crude birth rate of 18. I want you to calculate the annual growth rate as well as the doubling time. So I want you to go ahead and pause the video here, calculate the growth rate, calculate the doubling time. Once you've done that, unpause and come back to check your answer. So 18 minus 9, birth rate minus death rate, divided by 10 gives us 9 divided by 10. So in this example, we have a 0.9% growth rate. 70 divided by the 0.9 tells us that it's going to take 78 years for this country's population to double. So there's a lot of factors that affect human population growth. There are some factors that increase population growth. There are some factors that decrease population growth. But there are a few factors that we might think would decrease population growth, but that are frequently associated with population growth. So let's first talk about factors that increase population growth, then we'll kind of talk about those too. So our factors that increase population growth are high total fertility rates. High total fertility rates means higher birth rates. More births means more population growth. If we have a high infant mortality rate, so that one we have over here as a factor that decreases population, because a high infant mortality rate means people are dying, infants are dying. So we would expect that to decrease our population growth rate. But what we find is that in most countries that have high infant mortality rates, that actually drives up that total fertility rate because women have what are considered replacement children. And so what that means is that on average, they're going to have more children than a country with a lower infant mortality rate because they are concerned that they are going to lose an infant or a child. And so that high infant mortality rate and high child mortality rate can actually drive up our total fertility rate and can actually increase population growth. So those are our natural factors. Then countries that have high levels of immigration are also going to have increased population growth. So if you have a lot of people moving into your country, then that's going to increase your population growth. And then any factor that is going to decrease the death rate. So that would be things like access to clean water, access to good healthcare, access to nutritious food. All of those are going to increase population growth by decreasing the death rate. High death rate can also, although again, we would expect it to decrease the population growth rate, sometimes in countries that have a high death rate, again, it increases that total fertility rate. And so that can occasionally result in population growth. Okay, so the factors that typically decrease population growth rate, first, the two that we've already talked about, high death rate and high infant mortality rate. We can also talk about increased development as a population becomes more educated, as a population becomes more affluent. That tends to lead to increased education for women. It tends to lead to later in life reproduction, so delayed age at which women have their first child, frequently also because of a postponement of marriage to later in life. And so all of those factors that come along with increased development tend to decrease the population growth rate. Okay, so one of the factors that we talk about a lot in environmental science is what we call standard of living indicators. And when we talk about standard of living, what we're talking about is what is the quality of life for people who live in that country. So we can look at two different indicators for standard of living. We base the standard of living on gross domestic product and on life expectancy. So gross domestic product is an economic indicator. It tells us the total value of the goods and services produced by a country. Generally, your more affluent countries with a higher standard of living have higher GDPs. We'll also see what we call a per capita GDP or a per capita gross domestic product. So that's per person, because you can have a small country with a small GDP, but its per capita GDP could be quite high. So per capita divides the total gross domestic product by the population of the country to give us an indicator per person. And so the higher the per capita GDP, generally speaking, the higher the standard of living for the people who live in that country. Life expectancy is another fantastic indicator for standards of living, because this tells you how healthy people are. And when we are healthier, we have a better quality of life. And when we talk about life expectancy, what we're talking about is just the average age to which a person will live in a given country. This tends to increase with access to all the things that make us healthier: clean water, clean air, healthcare, healthier food, stable food sources. So as those indicators go up, we see higher GDP, we see longer life expectancy. We associate that with developed countries and developed countries with lower population growth. So the higher the standard of living, the lower the population growth is likely to be, even to a point of stable and non-growing populations or even shrinking populations. Okay, so our practice for 3.8 is to describe one environmental problem that is associated with a rapidly growing human population. Notice that I'm asking you to describe an environmental problem, not an economic problem, but an environmental problem, and propose a solution that a government could take to slow population growth. So remember, when we want to propose a solution, we can either think about a carrot or a stick. So we can think about incentives, or we can think about negative consequences. Okay, so now moving on to 3.9, which continues with the idea of human population growth and development and brings us into what we call the demographic transition. And so we have 4 stages of the demographic transition. We're still looking at birth rate and death rate and population change, but these are, generally speaking, associated with stages of development of a country. So as a country develops, the death rate starts to fall. So in stage 1, birth rate and death rate are very similar. As a country develops and access to clean water and healthcare and stable food, the death rate is going to start to drop. But because these countries are generally still very agrarian, And because it takes time for a population to adjust, the birth rate tends to stay very high. Now, as we enter stage 3, you'll see the death rate start to taper off and become more stable, and the birth rate will start to come down. And so in both of these stages, population is increasing, but in stage 2, it's increasing very rapidly. And in stage 3, the population is continuing to grow, but it is growing more slowly. And then in stage 4, as birth rate approaches death rate again, then our population starts to become more stable. Okay, so let's talk about the process of industrialization. So when we talk about industrialization, we are talking about the process of both the economic and the social transition from a farming-based economy and agrarian economy to an industrial or a manufacturing-based economy. And so we tend to talk about 3 stages of industrialization, even though we talk about 4 stages of transition. So there's some overlap in these 4 stages of the demographic transition with the 3 stages of industrialization. So when we talk about pre-industrialized or less developed countries, we are talking about countries that have not yet made the transition from a farming-based economy to an industrial-based economy. These tend to be very poor countries. They have low GDPs. They have low standards of living. They tend to have very high death rates and high infant and child mortality rates. And they also tend to have high total fertility rates because of the need for replacement children and agricultural labor. As countries industrialize, as they develop, they go through a transition. During that transition, the death rate is decreasing and infant mortality rate and child mortality rate are decreasing. And the gross domestic product starts to rise. Life expectancy starts to rise. And so those indicators of standards of living are starting to increase. When we talk about an industrialized nation or a developed nation, we are talking about one that has completed the transition from the agrarian economy to the industrial economy. They tend to have very low death rates, very low infant mortality rates. As a result, they also have very low total fertility rates. And as developed countries, they have high gross domestic products and they have a high standard of living, generally a long life expectancy. So if we look globally, the countries that you would expect, North America, Western Europe, and Australia, Japan, and South Korea are considered developed countries. Most of the world is still considered developing countries. These are countries that are making their way through the industrial transition, but have not completed the transition yet. Least developed countries are Central Africa and some of the Asian countries, Vietnam, Pakistan. And so these are the UN and the International Monetary Fund classifications, not mine. So these are these statuses that we've talked about. So pre-industrialized, industrializing, and industrialized. Okay, the 4 stages of the demographic transition do not line up perfectly with those 3 stages of industrialization. So just be careful that we're not mixing them up. So stage 1 of the demographic transition is the pre-industrial stage. In this stage, we have very high infant mortality rates, high death rates, because there simply is not access to clean water, stable food supplies, and healthcare. As a result, there's high total fertility rate. They also have very little access to education for women, to contraceptives, to any information about family planning. And there's a need for child agricultural labor and that replacement child concept with the high infant mortality rate. So they tend to have a very high birth rate, but that birth rate is balanced by accrued death rate. And so there's little or no growth in pre-industrial stage. at this point, there are virtually no countries in the world that are considered to be stage 1. When we talk about stage 1, the only areas that we consider to be stage 1 are isolated tribal communities. So some of the communities in the Amazon rainforest or other areas, but there are no countries that are considered to be in the pre-industrial stage. When we move into stage 2, now we're talking about those industrializing and developing nations. So we have modernizations that are bringing access to clean water, to better healthcare, to more stable food supplies. And as a result, both the infant mortality rate and the crude death rate decline. So we have a sharp drop off in those things that decrease population. But total fertility rate tends to stay high. There's still not a lot of education for women. There's not a lot of access to contraceptives, to family planning. There is still a need for children for agricultural labor. And it does take time for society to change. So there tends to be what we call a generational lag. So it takes time for that mentality of replacement children to change. And so initially in stage 2, you still have very high fertility rates and a rapidly declining death rate. This tends to lead to very rapid growth during stage 2. If we're thinking about our population pyramids or our age structure diagrams, we're going to have a really, really broad pre-reproductive cohort and a narrower reproductive cohort. So that's leading us to this rapid growth because we have the high crude birth rate and a declining crude death rate. We'll have some indicators of these stages. They tend to have still relatively low per capita gross domestic product, still a relatively short life expectancy because the older people in the population have not had access to the good healthcare, stable food supply. So we have shorter life expectancy. Relatively high infant mortality, but it is dropping, and definitely high total fertility rate. In most industrializing and developing nations, there is still a low literacy rate, and school and educational access for women and girls is still very, very limited. So moving on to stage 3, what we consider developed nations, industrialized nations. We have a modernized economy. We have a modernized society. This tends to increase family incomes. So the total fertility rate decreases as there are more educational opportunities for women, as both women and men delay the age of marriage and their first child to focus on careers and education. There's also much greater access to family planning and to contraceptives. So the growth rate begins to slow as the crude birth rate comes closer to the crude death rate. And so we see that slowing growth rate. When we look at indicators of developed or industrialized nations, we're looking at very high per capita GDP. We have long life expectancies, low infant mortality rates. The total fertility rate tends to be near replacement level, so 2.1, 2.0. And we have high literacy rates and high schooling and education for both genders. All right, and when we reach stage 4, these are post-industrialized or highly developed nations. These are highly modernized countries that tend to be very affluent. Total fertility rate declines even further as families become more wealthy, spend more time on educational and career pursuits, more leisure time, and that increased wealth and education brings even more prevalent use of family planning and contraception. So the crude birth rate tends to drop lower than the crude death rate, and we start to see populations decline. Our economic and societal indicators tend to be very high per capita GDPs. These have the longest life expectancies. The total fertility rate is going to be below replacement level, so it's going to be less than 2.1, and high contraceptive use rates. So 4 stages. Let's skip back here. Okay, so these are our 4 stages. Stage 1, pre-industrial. Stage 2, industrializing or developing. Stage 3 is our industrialized or developed countries. And stage 4 is post-industrial, highly developed countries. And so you can see the birth rate initially and death rate are both very high. Death rate declines through stage 2 while birth rate stays relatively high. In stage 3, the death rate is falling, but much more slowly, and birth rate falls rather rapidly. And in stage 4, birth rate continues to decline and death rate is low and stable. So population grows exponentially in stage 2, slowly but steadily in stage 3, and then we level off to no or negative growth in stage 4. Okay, so, oh, there's my slide. And we can see the matching population pyramids here. Remember, very broad pre-reproductive cohort in those early pre-industrialized and developing nations, very rapid increase during early developing nations. The increase slows down, begins to look like a house in stage 3 or industrialized nations. And we will actually wind up with that narrower base when we're in stage 4. Okay, and here's your FRQ for 3.9. I want you to identify the stage of this graph in which population is growing the fastest and explain why the population is growing the fastest in that stage. And I want you to describe one economic or societal indicator of a country in this phase. So that wraps up Unit 3. As always, if you have any questions, please let me know. Look forward to seeing you in class.